Welcome back, class. We're going to look at a system of linear equations in this standard, and where we can look at a system of inequalities later on. All right, now we're going to start by defining what is a system. A system of linear equations is where you have to solve two equations or more at the same time, ladies and gentlemen. So it's for us to find the solution of two equations at the same time, simultaneously. So let's look at an example. Without further ado, consider 2x plus y equals 5 and 3x minus 2y equals 4. Ladies and gentlemen, we need one x and one y that works for both of them. All right? Now, the procedure I use in this rather is solving for y, because in algebra 1 you had to solve for y a lot, and because we just did literal equations, so let's get a variable by itself in both equations. So for the first one, we do the additive inverse of 2x, which is negative 2x on both sides of the equations, and we end up with y equals negative 2x plus 5. This is y for the first equation. Similarly, we're going to do the same thing for the second equation. We do the negative 3x on both sides equation, which is the additive inverse of positive 3x. So we end up with negative 2y equals negative 3x plus 4. Right now, we're going to do the multiplicative inverse of negative 2, which is going to be negative a half, or if you wish, you can just divide by 2. That works as well. But remember, I want you to get used to multiplicative inverse and reciprocals. So we end up with 2 over 2y and 3 over 2x and negative 4 over 2 simplified, 3 over 2x minus 2. Now we got the two equations, ladies and gentlemen. So what we're going to do, get both of the right sides of the equation equal to each other, both of the left side of the equation equal to each other. What do I mean by that? Look at that. Right side, y equal y. If y equal y, then negative 2x plus 5 must equal 3 over 2x minus 2. Because if the right sides are the same, the left sides must be the same. As a result, we want to isolate x on the left side that we have equated, and we end up with adding the additive inverse of negative 2, which is 2x on both sides, additive inverse of negative 2x, that is. So we end up with 5 equals 7 over 2x minus 2. Ladies and gentlemen, that has to do with combining like terms, and remember, with fractions, what you do with fractions, in order to add them, you need common denominators. That's where the 7 over 2x come into play. Ladies and gentlemen, we still want x by itself, so we do the additive inverse of 2. So that becomes 5 plus 2 and 7 over 2x minus 2 plus 2. So now on the right side we get 7, and on the left side we have 7 over 2x. Ladies and gentlemen, what happens here, to get x by itself at this point, I must multiply by the reciprocal of 7 over 2, which becomes 2 over 7. I multiply every term by 2 over 7, and ladies and gentlemen, I obtain 14 over 7 equals 14 over 14x. Hence, x equals 2. Ladies and gentlemen, that's just x equal 2. We are not finished at this point. Now, we want to find a y. Ladies and gentlemen, what we do, we take the equation y equals negative 2x plus 5, and we're going to substitute x equal 2, which is what we just found. So by substituting, we get negative 2 times 2 plus 5. Hence, we have negative 4 plus 5 and y equals 1. That means, ladies and gentlemen, we have x equal 2, we have y equals 1. That means the solution for the system that was presented is 2, 1. which means 2 comma 1. If plug in both equations, it will stay true. The statement of both equations will stay true. All right. Now, this solution is the solution of the system, as you see. If we look at the two equations as was given to us, we have 2x plus y. Remember, x is 2, so 2 times 2 is 4. And y is 1, 4 plus 1 is 5. Look at the second one. 3 times 2 is 6. And minus 2y, 2 times 1, so that's a negative 2. 6 minus 2 is 4. Alright, ladies and gentlemen, make sure you know, if you were to graph this, what will happen? 2 comma 1 is where the two graphs will intersect, which means this is where they cross each other. Alright, let's look at another one. I would like you to give this a try before I go through it. Alright, make sure you follow the step that was shown. If you need to, go back and look over it. Alright, this is what you should end up with. Ladies and gentlemen, you need to isolate y in the first equation. Alright, so we start by doing the additive inverse of x and go from there, and we do the multiplicative of 4 at this point, and we end up with this. So y equals negative 1 over 4x minus 3 over 4. That is what y equals. This is y for the first equation. Similarly, we're going to do the same for the second equation. Of course, we do the additive inverse of 5x. And ladies and gentlemen, we have negative y equals negative 5x plus 6. So we do the multiplicative inverse with the negative 1 over 1. And we end up with y equals 5x minus 6. Alright? And this is our second equation. We had the first one, and now we have the second one. Remember, the right side, if the right sides are equal, the left sides are equal as well. So we're going to work with the equation of the left sides. So we end up with, of course, negative 1/4 x minus 3/4 equal 5x minus 6. And ladies and gentlemen, what we did here, remember that technique I told you? In order to get rid of the fraction, you multiply everything by the denominator, the greatest denominator you have there. So in this case, we multiply everything by 4 just to get rid of the fraction. And we end up here with negative 4 over 4, negative 12 over 4, 20 over 1, and negative 24 over 1. Ladies and gentlemen, by simplifying, we get negative x minus 3 equals 20x minus 24. And we have negative, that's just copying the problem over to get to the next page. Negative x minus 3 equals 20x minus 24. We need to do the additive inverse of the x to get all the x's, which means the variables on one side of the equation. And ladies and gentlemen, we have negative 3 equals 21x minus 24. And at this point, we do additive inverse of negative 24, and we get 21x equal 21. At this point, we multiplicative inverse of 21 or divide both sides by 21. And ladies and gentlemen, we get x to equal 1. Alright? So ladies and gentlemen, this says x. So all I have to do is to go to one of the equation, plug x in, and we should obtain y. This is what happens here. Alright? Since x was 1, in the equation y equals 5x minus 6, we plug in 1 for x. And ladies and gentlemen, we get 5 minus 6, and we get y equals negative 1. Since y equals negative 1, we know x equals 1. So the solution of the system is 1 comma negative 1. Ladies and gentlemen, if we were to plug this in here right now in both equations as they were given, So for x is 1, y is negative 1, we would have 1 plus 4 times negative 1. That, of course, equals negative 3. So that statement is true. And let's look at the second one. 5 times 1, which is 5, minus a negative 1. So 2 negative makes a positive. So it becomes 5 plus 1, which equals 6. This statement is also true. Therefore, this is the solution for this system. Ladies and gentlemen, I leave you with these three systems of linear equation. I would like you to try them. You need to at least complete 2 of them for a grade. You need to do 2 of them. I can work one with you, but you have to complete 2 of them on your own. Remember, get y by itself. Then equate the right sides and the left sides. Get the variable by itself, which would be x in this case, and substitute to find the other variable. All right? Comment questions and I will assist you as needed. Thank you.